Everyone for coming to the webinar today. My name is Ben Chelf. I'm the CTO of Coverity. We are a software provider of tools that find bugs in software automatically using a technique called static source code analysis. We're fortunate enough today to have with us Gordon Thompson. He's the Director of Development at Eris. And he's here so that he and I can have a brief dialogue and a little bit of question and answers with each other to discuss some of the issues around software quality, how to bring software quality into your organization, and the things that he does at Eris to make sure that their software is very reliable. As I mentioned, this session is focused a lot on questions and answers, so the format will be as follows. First, I'll give Gordon the chance to briefly introduce Eris and talk about what they're developing and why it's so important for them to have a very highly available and robust piece of software. And then I'll ask Gordon a few questions about their software quality, about things that they've done in the past to address the software quality problem, as well as things that they're looking to do in the future to address the software quality issue. And then we'll turn the tables, and I'll give a brief introduction of Coverity, what we do, the type of technology that we have to help with the software quality issue. And then I'll give Gordon the opportunity to ask me some questions about our technology, about how we see it working for people out there in the field and what it holds in the future. And we would like to, in this particular webinar, open it up and have an extended period of question and answer session from you, the audience, and we invite your participation. So we ask that you send in questions at any time that we're chatting, and in the end we'll have hopefully between 20 and 30 minutes to answer your questions, either to Gordon about his experience with software quality or his experience with static source code analysis tools, or to me about what I view as the importance of static analysis tools and how our static analysis tools are used out there by hundreds of customers every single day. So with that, I'd like to turn it over to Gordon, who will give you a brief introduction about Eris. Gordon?
Thank you, Ben, for that introduction. Hello, everyone. Welcome. My name is Gordon Thompson. I work at Eris Interactive. We develop, and I'm the development director here at Eris Interactive, and have been working with this company for one form or another over 15 years now. And I'd just like to give you a little bit of a background as to Eris and what we do. Right now, Eris is primarily focused on the cable industry, and we provide communications equipment, both head-end and customer premise-related equipment, that allows our customers to provide telephony and high-speed and video services to their end users. We are standards-based, of course, and our customer base, the next page please, is the top 10, top 20 MSOs in the world, from Comcast, Liberty to BBC, and many others that you see here. Next slide, please. Now, with Eris, our strength and claim to fame is our long experience in building highly available and highly robust systems. I personally come from a telephony background where it's all about lifeline service, and we have a joke internally about it. It's not about life and death, it's much more important than that. But that gives you a sense of how seriously we treat and work towards having a highly available system. And on the next slide, I give you try to appreciate some of the things that we do and attempt to do in terms of providing highly available service. Right now, we measure the availability of our systems from the reports from our customers, and we achieve greater than 99.999, the 5 nines availability for the systems that we provide. And we're always on the lookout for things that we can do better, either better tools, better processes, better architectures that allow us to maintain that availability and also decrease the issues that might cause that availability number to be impacted. Some of the things that we do, next slide please, is to ensure software upgrades don't cause any interruption to service. We have redundancy built into our head-end equipment, and we do all sorts of algorithms in our head-end equipment to ensure that faults are detected, and when faults are detected, that the equipment automatically switches over into a redundant piece of equipment. And the reason for that is that the density involved with our network equipment, for example, the products we sell called the C4, can have in excess of 50,000 subscribers off of this one device. So having an impact, say, for a software upgrade is in excess of 40 seconds will impact our net 5 nines availability for those customers. So we go through extraordinary lengths to ensure the systems are highly available. So that's my introduction to myself and ARIS and what we do to supply software. So availability and reliability is such an important aspect of what we do, one of our core competencies, and things we do to, or strive to do, to ensure that we maintain that availability.
Excellent. Thanks, Gordon. So my first question has to do with software defects. Obviously, if you have such a high availability system, you probably have some experience with weeding out software defects in your code. So describe for us, one of your first memorable defects that you've encountered in your life. What went wrong? How did you find it? What was the process like for finding it? And what was the real pain that it caused you?
Oh, thank you. Yes, certainly. One of the most memorable ones I've personally encountered, and I guess it's a learning exercise, is the use of storage. And in writing a procedure, a structure was created on the stack, on the heap, and that structure was then addressed through returning that address value in the return statement. So, obviously that's not a very wise thing to do in hindsight, but at the time it was an easy mistake to do. However, the consequence was that for the most part, the software ran just fine, and it ran fine with debug enabled and all the associated overhead associated with that. And for whatever reason, the data on the heap did not get corrupted. However, when optimization was turned on the compiler, then things just didn't work. And sometimes it would work, sometimes it would not work, and trying to find that particular issue took an awful lot of time, recompiles, putting in debug statements, because the issue never occurred with source level debugging turned on, and it only occurred with it just being disabled. And so it took a long time, several days of time, to track down this, what one might argue should have been flagged by the compiler as returning an address that had been allocated in the heap of the called procedure. So that was a memorable, and it was, I guess, memorable because it was so painful.